Hi, and welcome to Allen High School's continued discussion of reaction stoichiometry and with a particular focus on limiting reagents and limiting reactants. Now, we're working on a method that I call BSA. You can use a variety of acronyms here. And it's somewhat different than maybe what your teacher did if you're joining us from a place other than Allen. But I think you will find if you have a little patience, there's a big win in the end. And so let's forge ahead and see what we can do with this. Now, in this example, this is a very typical example in chemistry. In fact, sometimes I get a little tired of this. We've got hydrogen gas and nitrogen gas forming ammonia. This is called the Haber process, by the way. If you end up being in IB chemistry, they really want you to know that. All right. So down here, I have done our first step. And our first step in this is to write a balanced equation. You cannot do stoichiometry if you don't have a balanced equation. So I have our balanced equation down here, 3 hydrogens, nitrogen, and these are all gases. So it probably would have been a good idea, especially as we try to decide how to do one of our first steps, to realize that these are all gases. Whoops, plus. Okay? So hydrogen plus nitrogen gives us ammonia. So step 1, write your balanced equation. Step 2, calculate your moles. So if you want to put it above here, I think sometimes it can help. I've got 48.0 liters, and it points out that it's STP. That's going to be very useful information. Here I've got 15.0 grams of nitrogen gas. So step 1 is to convert to moles. If I have a gas, and only if I have a gas, and if that gas is at STP, I get to use 1 mole of a gas at STP is 22.4 liters. And when I do that calculation, I get 1.92 moles. Now, for the nitrogen, I'm going to use the molar mass. Mass to moles, use molar mass. Don't forget that it is diatomic, so you have to have a molar mass that is double what you get from the periodic table, or 28.02 grams. And if I do that, I have 0.5353. All right. Now, some of you can look at this and say to yourself that I need 3 times as much hydrogen. There's a 3. I need 3 times as much hydrogen as I have nitrogen. And I have way more hydrogen than I need. In other words, we would say hydrogen is in excess and nitrogen is limiting. Now, some of you may not have seen that, and that's okay. What I'm asking you to do here is just pick one. Just pick something to be the limiting reactant, and if you get a negative number at the A step, you know you picked the wrong one. Erase, go back. It's not a whole lot of work. All right? So nitrogen is our limiting. So our next step is to write down our limiting. Now remember, we lose reactant, we gain product, so we want to put those signs in. And then we want to go through and write our limiting amount on each one, plus 0.5353. Everything is going to depend on our limiting reactant. So we're really next going to use the mole ratio to hop from that limiting to the other substances. So let's take a look at that. I want to get a different color pen here. All right, there we go. All right. Now, we don't need the mole ratio for the nitrogen because that's our starting point. And remember, it's where you're going to. So in the column where you are, that number goes on top because we're really going from nitrogen to ammonia. So we put the 2 on top and the 1 from the nitrogen. It's always where you're going to over where you're coming from. All right? And notice that when you're in this column, the balancing coefficient from that column is the one that's on top. So for the hydrogen, it's going to be a 3 because there's 3 hydrogens for every 1 nitrogen. Okay, that's really what we're doing, is we're taking the hydrogen moles and we're multiplying it by 3 moles of hydrogen for every 1 mole of nitrogen. That's what that ratio means, all right? So now that's our next step. That's the shift. That's what's going to happen as it shifts from reactants to forming products. So now our last step is to add, I almost said, I guess I will, add the BS, add B plus S and you get A, all right? And so we have none of our nitrogen left over. So that tells us right away that it's our nitrogen that's our limiting, because our limiting runs out. And our hydrogen is our excess, because I'm going to have extra or excess hydrogen left over. So I've got 0.5371 moles left over. Now, if this had been a negative number as opposed to a positive number, you would have had to erase this here and started fresh. You wouldn't have to erase that. That would be still to go. You'd just have to erase these little 4 blocks here and start fresh. And I have 0.5353 moles of ammonia. All right. So now that your table's filled out, you can really get to anything that you need to get to. All right. So let's take a look. I'm going to have to erase this, but you have that in front of you, hopefully. So this says now we've identified our limiting, we've identified our excess, and now what we want to do is talk about how many liters of hydrogen were left over. Well, up here we had 0.5371 moles. So if I've got a gas and it's at STP, I can take those moles and I can convert them back to liters using the 22.4. So I've got extra hydrogen. So now if I want to do a fun reaction, like maybe blow it up with oxygen in the air and cause a fun flame, I could do that because I have some extra left over. In fact, I have 12 liters. Okay, I'm not going to blow that up. That's way too much to blow up, but it still would be kind of fun to think about. How many grams of nitrogen? Well, I had 0 moles. It was the limiting. It ran out, so I have 0 grams. What was my theoretical yield of my ammonia? All right, to get to my theoretical yield of ammonia, I'd have 1.071 moles. Moles to mass use molar mass. And for ammonia, it would be 17.04 grams for every 1 mole. All right. And, and this asked, actually, I'm lying to you. Read carefully, Dr. Leggett. Ammonia in liters. See, but it does prove to you you've got moles. Once you have moles, you can very quickly get to any unit you want. In fact, Mr. Harridan said when he finally, had worked on this a little bit, he goes, once you filled out the chart, all the other questions are trivial, and they are. So this would get me to liters of ammonia. This would get me to grams of ammonia. And I haven't calculated those numbers. So when I check your notes, I'm going to be looking for those numbers to be calculated. So until then, this is signing off.